We have to transition towards more renewable energies. Open any newspaper, turn on any radio, watch any TV channel.
Once in a lifetime energy transition.
It's a transition strategy.
An incredible transition.
To transition to clean energy.
And you will hear about it. I am focusing on one of the main challenges, bringing enough electricity to all households at all time, taking into account this energy transition. When the network was built years ago in Belgium, the demand was estimated and cables were installed with a safety margin of 40%. However, in the meanwhile, our consumption has changed and this infrastructure was never intended to charge multiple electrical vehicles at the same time. Replacing the entire grid is not a viable option. It would be too expensive and not future-proof. One solution is to make the grid smarter, to use the available capacity more efficiently, to detect congestions, and to take preventive measures. In my PhD, I focus on forecasting individual households' consumption. This allows to detect congestion early on and to trigger mitigation strategies. However, forecasting individual household consumption is challenging because of the high stochasticity. Indeed, you know you'll cook tonight, but do you know the exact time at which you'll start cooking? So how is an algorithm supposed to figure this out? I implemented and published several algorithms, all of them solely based on historical consumption and calendar information. I aim for the lowest data requirements. Indeed, we can't expect to know the exact number of bedrooms of all households in a real-life setup. I also investigated different approaches: deterministic, probabilistic, one global model for all households, individual models for each household, and the probabilistic global approach outperforms the other. Indeed, it generalizes better to different datasets and gives us information on the uncertainty of the prediction. Finally, all approaches are computationally efficient in order to scale to any number of households. I would like to share general, but nonetheless key takeaways of my research. First of all, give enough importance to dataset cleaning, pre-processing, and thoughtful normalization, as it usually makes a major difference in results, especially in real-life industry setups. Ensure scalability and explainability of the models for them to be used and trusted. Use several open datasets and share your code to allow for reproducibility, for comparisons and generalization insights. And finally, remember that the most advanced complex methods don't always perform best. Now let's use these key takeaways to bridge the gap between industry and research and to enable the energy transition.